So this video has some additional information on some of the conceptual Mohr circle problems that could be on your exam or in your final exam. It's an extra set of notes that I had, and they're not neat, they're just handwritten, and it covers some of the same ground of what we've been talking. But since I have the notes there, I thought I would talk through them. Again, it's some of the same information. So these are some general principles that you need to be aware of on Mohr circle style exam questions. Again, there's an original area, which is usually a beam shape or something. It's sometimes called a cross section. Typically, it's going to have an original set of axes that might be called XY, IJ, PQ, apples, oranges, Ralph, James, whatever. And then there's a set of rotated axes or some different coordinate system that you could call UV, PQ, JK, or whatever. Those axes are 90 degrees on the cross section, and they're 180 degrees apart on Mohr circle. This original area has a Mohr circle. And again, this Mohr circle is the locus of combination. So remember, the horizontal axis is moment of inertia. The vertical axis is product of inertia. And so the points that plot the circle out are all of the combinations of moment of inertia and product of inertia at every orientation for this given cross section or this given area. Typical information that you're given some combination of information given. You might be given a center, which is I average, or it gives you I average, which is the center. It may give you the moment of inertia about one axis, some IX, some IP, some IR, some IA, and that number can be greater than I average, which means it's on the right-hand side of the circle. It can be less than I average, which means it's on the left-hand side of the circle. Or it can be exactly equal to I average, which basically means it's either at the top of the circle or the bottom of the circle. It might give you the product of inertia for the original area. And so IXY, IPQ, IRS. And the product of inertia can be negative. If that's true, then the original set of guys that you were given, the IPQ or RS, are principles. Then they're your max or your min. If you're given a product of inertia that's not zero, then your original IXY are not principal. The product of inertia that you're given can be positive, which means it's going to plot somewhere on the top part of the circle, or it can be negative, which means it'll plot somewhere on the lower half of the circle. The problem could say that the IX or IMIN or the IP or the IQ or the IR that you're given are max or min, or it can say that they're principal values. And if it says that, you go, aha, so their IXY is zero, and they're going to plot at the 3 o'clock position, which for IMAX, or the 9 o'clock position, which is IMIN. So you can read the problem carefully. So again, in terms of typical information, you could be given an angle. It could be a theta on the cross section, or it could be 2 theta on the Mohr circle. It could be an angle from IX or IP or IR to IMAX, which would be a major principal angle, a theta P1. Or it could be an angle to a minor principal axis or to IMIN, and that would be theta P2. And so you're given some angle. So given all of these pieces, what are you asked to find? You might be asked to find a radius, I max or I min, an angle to I min, which is theta P2, um, on the area, which will be 2 theta P2 on Mohr circle. Or you might just be finding an angle to I max, which is sometimes called theta P1. Or that's an angle to a major principal axis, which is basically I max. So it's theta P1 on the area, or it's 2 theta P1 on the Mohr circle. Usually you're asked to find the smallest of the two, but you could be asked to find the other. So for example, if your point is closer to the I max, more often than not, you're probably asked to find that guy. But you could be asked to find the larger angle. You might be asked to find the center. You might be asked to find an I about some rotated axis, about some angle from the IP or from the IR, or it could be an angle clockwise from a max or min, or clockwise from another P or Q, or it could be an angle counterclockwise from P or Q. And again, it's theta on cross section, or it's 2 theta on the circle. You might ask to be able to find the product of inertia associated with that point, with that rotated point. So the product of inertia is basically the vertical. You're usually given enough information to build out this triangle. And usually the vertical is the product of inertia. And usually the base is the IU minus the I average, or IX minus IY divided by 2. Once you can build that triangle, then you can get the angle, or if you have the radius and the angle, then you can get the sides of the triangle. So here's some examples. Again, more examples. Center is 20 inches to the fourth. You're given an IA, which is 12, and you're given a product of inertia of IAB, which is 0. And so this basically tells you, aha, this is a principal. IA is a principal. And so since A is 12 and the center is 20, then that means IA is a minimum. You're asked to find IU that's rotated 20 degrees clockwise from A on the original section. So original 20 degrees clockwise from A on the original cross section, or the original area, is 40 degrees on Mohr circle. And so you have a 40-degree angle here. The radius is 8. And so that gives you enough information to build out this triangle. So 8 sine 40 is 5.14. 8 cosine 40 is 6.13. So the coordinates of this point is the center 20 minus 6.13 is 13.87. And then the product of inertia at that point is 8 sine of 40, which is 5.14. Here you have a center, which is 200 times 10 to the 6 millimeters to the fourth. You have an IP, which is 320, and an IPQ, which is minus 60. And you're asked to find the theta to a minor principal axis. And so you can draw the circle. The center is 200. You have a point IP, which is 320, which is to the right of the center, minus 60, which is down here. So this is 320 minus 60. And you're asked to find the theta to the minor axis. And you're asked to find this large angle here. But really, you need to find the 2 theta here to the Imax first. And so you set up this triangle, and the right side of the triangle is 60. The base of this triangle is 320 minus 200, which is 120, and that's 2 theta. So 2 theta is the inverse tangent of 60 over 120, which is 26.6 degrees, is our 2 theta. And so our 2 theta P2 is 180 minus 26.6, which would be 153.4 on Mohr circle, and divide that by 2. On the original area, our theta P2 is 76.7 degrees, or on our original area, our theta P1 is 26.6 divided by 2, which is 13.3. So again, we're given a center, we're given enough information for a point, and then from that, you can get your angles. Finally, we have a center. We have a reference point, which corresponds to a set of axes, and we want to find I min, or we want to find I max. And so the center is 40. Our reference point is 2510. So the 25 is to the left of 40. The 10 is positive, and so that plots this point here. So once you have that, so that enough information to build out this triangle, which is 40, 25. So the difference is 15. The height is 10. This is 2 theta. Our radius is the square root of 15 squared plus 10 squared, which is 18. My 2 theta here, the tangent of 2 theta is 10 over 15. My 2 theta is 33.7. My theta is 16.9 degrees. And so that gives us an angle from this PQ coordinate system to I min. And since we know the radius now, our I min is 40, which is the center, minus 18, which is 12. The I max would be 40 plus 18, which would be 58. And then you can find anything else of interest. So again, just more principles, more practice of these conceptual style, Mohr circle problems. Again, keep reviewing this till you can read the problem, know what you're given, and find what you're asked to find.